In this video, we're going to be looking at writing equations of graphs. Here are the directions for the first few problems. Each graph below shows all the real zeros of a polynomial function. Write the equation of the polynomial function of least degree having the graph shown and leave your answer in factored form. For this problem, I'm going to start off by finding my zeros. And I notice that my graph goes through the x-axis at each of those zeros as opposed to just touching the x-axis and bouncing back off. So I know the multiplicity of each of these zeros is odd. So the least odd number, smallest odd number each of these could be is 1. So the smallest multiplicity for each of my zeros is 1. So there's the general form for my function. Notice that each factor has an understood exponent of 1 or multiplicity of 1. Now I'm not sure what A is by looking at my graph, but I am given information in my problem that tells me my leading coefficient is going to be 1 or negative 1. And there's a couple of different ways that I could go about figuring it out. One way is just to put this in the calculator with A to be 1 or A to be negative 1 and see what happens to the graph. If the degree of my function is odd and my leading coefficient is positive, then the general shape of my graph is going to be something like this. Not sure what's going on in the middle part of my function, but that's the general shape of the graph of odd degree and a leading coefficient that is positive. So my leading coefficient in this particular problem has to be positive. So in this case, it's positive 1. And I don't really need the 1 there, so I can write my final answer like this. And you can always put this equation into your calculator and graph it to see if it matches with the graph that you're given in the beginning of the problem. Problem 2, find a polynomial of least degree having the graph shown. Use a leading coefficient of 1 or negative 1. My zeros are at negative 2 and 3. And notice how my graph touches the x-axis at negative 2 and then bounces back off as opposed to crossing the x-axis. Same thing with the 0 of 3. That means the multiplicity for each of these zeros is 2. So there's the general form for my equation. I just need to figure out whether my A is 1 or negative 1. And I can put either one of those in the calculator and graph it and see what matches up. But I also know that in general, if my degree is even and my leading coefficient is negative, my graph is going to be in this shape. Don't know what's going on in the middle of the graph, but I do know that as I go out toward positive infinity or toward negative infinity, my graph is going to be going down toward negative infinity. And you can always go back to what we've learned about parabolas. I know that if I have a parabola that has a positive leading coefficient, it's opening up. If my leading coefficient is negative, my graph is opening down. It's the same way with higher order polynomials. So in this case, my leading coefficient is negative. So there's my answer. Problem 3. The function defined by the following has the graph as shown. Use the graph to factor the polynomial. I'm going to start off by finding the zeros. Then I'm going to determine if their multiplicities are odd or even. Now I know my equation is degree 4. So when I list out the multiplicities, I know that they have to add up to be no more than 4. So the only way that's going to happen is if I have a multiplicity of 2 here, 1 here, and 1 there. So that's a total of 4, which matches the degree of my function. Okay, so there's the general form of my equation. Now I don't really need the minus 0 here, so I'm going to get rid of that. And I also know that when I multiply out my first terms here, I'm going to have 1x to the fourth. Remember that with this factor here, it has a multiplicity of 2. So I'm supposed to have a leading coefficient of 1. That means a is going to be 1. So there is my answer. And again, I can always go back and put this answer in the calculator and see if it matches up with my graph that is given to me in the original problem. For problem 4, I'd like for you to pause the video and see if you can answer this one on your own. My leading coefficient here is going to be 1, so this is my final answer. Problem 5, I'm asked to find the polynomial function of least degree having the graph shown. So I'm going to write out the general form for my function. So here you can see my zeros and the general form of my equation. Now notice that the multiplicity for all of my factors is 1 because I know that the multiplicity for each of these zeros is odd. So the smallest odd number that I have is 1. So from here, I'm not given any information that is obvious like in the other problems to figure out what my A is. In the first couple of problems we were told that A was either positive 1 or negative 1. And then in the next couple of problems, I had the equation written out so I could look at my equation and figure out whether my leading coefficient was 1 or negative 1. Here I don't have that, so I'm going to have to do something different. And what we're going to do is to use this point 0, negative 9. This is an x value, this is a y value. I'm going to put this point into my formula, and I'm going to solve this equation for A. I'm going to start by simplifying what's in parentheses. Then I'm going to multiply all of those numbers that are in parentheses. Now I have a simple one-step equation. I need to divide both sides of my equation by negative 18, and I get A to be 1/2. So now I plug this A back into my original general form of my function, and there's my answer. Now to check it, to be sure that I have the right answer, I've entered my equation into my graphing calculator. I've set my y minimums and maximums to correspond with my graph. So looking at my graph, it looks like it's about the correct shape. And then I can look at my table to see that I have the point 0, negative 9 in my table, just like it is in my graph in the problem that I originally started with. In this problem, I'm asked to write the equation of the graph. I'm going to start off by finding my zeros and my factors in order to get the general form of the function. So there's the general form of the equation. I do want to remind you that if I have a graph that's shaped like I have, sort of like this, then I know that the degree has to be odd. And the least degree here, it would indicate that each zero has a multiplicity of 1. So I'm going to use this point 0.024. I'm going to replace x with 0 and f of x or y value with 24. Simplify what is in the parentheses. Multiply what's in parentheses. And now we need to divide both sides of my equation. By 12, I get A to be 2. So I put that back into my general form for the equation. And there's my answer. And again, I can put this into the calculator and see if it matches up with the graph that I'm given. All right, I'm going to start off by finding my zeros. Now, what I want you to notice about this problem that's different than the previous problems is that at the 0 of 2, my multiplicity is even because my graph doesn't cross the x-axis, just sort of touches it and then bounces back off. So the multiplicity here has to be even. So the least degree means that multiplicity is 2, since 2 is the smallest even number. So the general form for my function is given here. I can easily see that my y-intercept is the point 0, -2. So I'm going to put 0 in place of x, -2 in place of f of x, and solve. So on my last step, divide both sides by equation by -60, and I get a to be 1/30. So there's my answer. And again, I can put this into my calculator to see if the graph and the table match up with the original information that I'm given.